Okay, number 4 from the homework. First question I have for you guys, and I don't want to pick the numbers. It's going to take too long. How do I know I have to do this indirectly? Other than that was the topic on Friday. Go ahead, Luke. What do you have? In the proof statement, perfect. In the proof statement, I'm proving something does not happen. All right, so I know I have to do this one indirectly. So let me set this up. I have no idea what that is. I don't know where that came from. Here we go. Okay, so there are my givens, and you guys know in an indirect proof, one of the first 2 steps has to be the assumption. This is actually the part I worry about the most, believe it or not. How do you get your assumption? Mike? Thank you. Please do not go to the givens for your assumption. It always is from the proof statement. So the opposite of what I'm trying to prove is AD bisects BAC. So AD bisects angle BAC. Now you can use that as a given. Please remember that. Use it as a given. All right, let's look up here. Your goal is to contradict a given. I gave you 2 of them. Which one is going to be easier to contradict? D is not the midpoint of BC by saying D is the midpoint. So somewhere along in your proof, sooner or later, you're going to tell me that D is the midpoint of BC. But how are you going to know if D is the midpoint of BC if what 2 segments are equal? BD and DC. So let's do that first. Let's get BD congruent to DC, so D will be a midpoint then. Well, how am I going to get those segments congruent if the triangles are congruent? So that's what I want to do with you first. Get those triangles congruent. I believe there's multiple ways of doing this.
Pardon the interruption. We will be having our first lockdown drill very shortly. It's important that you follow the direction you're.
Okay, let's get back. Our goal was to prove the triangles congruent. I had BA congruent to CA from the givens. A couple different ways you could have gone from here. Remember what we said, our assumption was AD bisects BAC, so you could have said those 2 angles were congruent. So what do I have? BAD and CAD. So BAD congruent to CAD, definition of a bisector. And then we could have went up top and said, I see a reflexive side AD. So AD congruent to itself by reflexive. And then that should have gave you enough info to say the triangles are congruent. What method? Side angle side. I don't know if anybody did this as well. Because these 2 sides were congruent, what type of triangle was ABC? It's isosceles. What's across from the congruent sides? Congruent angle. So you've also could have said angle side angle. You could have said angle angle side. So any one of those 3 would have worked perfectly. So we have BAD and CAD. So triangle BAD is now congruent to triangle CAD. You pick, well, you can't pick anything. I did it a certain way. So that would have been side angle side. Now, if those triangles are congruent, what corresponding parts in particular that we needed are congruent? BD and DC by CPCTC, so BD and CD. CPCTC. Now, don't think, you don't have a contradiction yet. You haven't contradicted a darn thing. But now that A, B, and CD are equal, what do you know about point D? It's a midpoint. So D is the midpoint of BC. And I'm pretty flexible about the reason you would use here for it being the midpoint. I will not be flexible, though, if you just write definition of a midpoint. That doesn't tell us anything. If you say a midpoint splits it up into 2 congruent segments, that's fine. I just wrote, if you notice on the answer key, because BD is congruent to CD. That's why it's a midpoint. And now what do I have now? What do I have in my proof now? in the givens and in step 7. That's a contradiction, meaning my assumption is false. So the opposite, AD does not bisect angle BAC. That's a true statement. And again, assumption led to a contradiction. And again, from Friday, please tell me what lines your contradiction is. When I say contradiction, I don't mean your assumption and your proof statement. That's not what I'm looking for. What did you personally contradict? Step 1 given, and then step 7 that it is actually a midpoint. Okay? Other questions that you wanted to ask? Because it's day 2 today, I'm going to do one with you, or we're going to do one together, and then you're going to go on your own and show me that you can do these. My hope is they seem a little easier because, like I said, the ones I gave you for over the weekend should be the toughest we've done all year, or toughest we'll do. All right, so let's see if we're picking this up or not. I'll let you guys go ahead, set it up, give you a second or two, set this up. Everyone see the proof statement automatically? I know I got to do an indirect proof or proof by contradiction. So go ahead and set the proof up. I'll ask somebody in a second what they think the assumption is. Okay, first question. What's your assumption? What is you're assuming what's true? Who has 10?
CA bisects.
There we go. CA bisects BD. And again, I can't stress this enough. Use it. Use that assumption you're making now. All right, our goal, contradict one of the givens. Well, I gave you 3 of them. There's 3 givens up there. Which one is the easiest one to try to contradict? Here we go, 10 again. Go ahead, Luke. Which one's the easiest to contradict?
Does not bisect.
So we're going to try to show it is. Oh, hold on.
I mean, does not congruent.
Okay, AB not equal to CD, so we'll contradict it by saying it is equal. So let's get AB and CD equal. How? Only if the triangles are congruent. And I love this proof because I gave you guys nothing. No sides or angles to begin with. You are on your own for all 3. So at least tell me one thing I can use to prove them congruent. Here we go. 3 in a row. 20.
Angle BEA and angle CED are congruent.
There you go. We got a pair of angles. So angle BEA congruent to CED. Little verts. Vertical angles are congruent. Thank you for those pair of angles. Next up, what else can you get from the triangles? Here we go. 4. What else can I have? All right, I like it. I got right angles at angle D and angle B. Not that they're congruent yet, but just that they are right angles. How do you know that, Rachel? What? Watch your mouth.
Perpendicular lines form right.
Yeah. If you remember on Friday, we used definition of an altitude. All right, well, I don't have an altitude here. I just have perpendicular lines. Now you can tell me they are congruent. One more pair of something. And you know it's not going to be angles because I already have two pair. Angle, angle, angle. Not a way. Let's go 6. I have the right angles. I have the vertical angles. I need another pair of something that says they're congruent to prove the triangle's congruent. BE is congruent to ED because what did our assumption say? There you go. That's what I'm talking about. Use your assumption. Use it. BE congruent to ED. Definition of a bisector. And I don't know about you guys, I think that's good enough. What method now for the triangles being congruent? Here we go. 18, what method? You're darn right. So let's see, BAE. Let's see, guys, if I go BAE, I got to go DCE. Angle, side angle. Why was it so important to get the triangles? So now you could say what? Even though the givens say otherwise, we now know that AB is congruent to CD by CPCTC. What do we have now in our proof? We have a contradiction. That must mean our assumption is garbage, false. So now we can say CA does not bisect BD. Assumption led to a contradiction. And again, just a reminder, remind me what lines the contradiction is on. And remember, the contradiction is not the assumption and proof statement. It's from your given and wherever you contradicted it, which for us would have been step 8. Questions from you guys? Okay, you have the remaining 5 for homework. They should seem a lot easier. I would like to please check 2 and 3 when you're done with them. Okay, so when you're done with 2, let me know. When you're done with 3, let me know. And then the rest are all up on Aspen for you to check yourself. Okay, so let me know when you're done with 2 and 3. Work with each other if you'd like. Your call.